So today we are going to learn two important concepts, that is probability mass function PMF or दूसरा probability density function which is the PDF. Okay. So firstly we will learn the first concept, that is the probability mass function. So let's try to understand concept number one for today, probability mass function. It is written as PMF as I told you. If x is a discrete random variable, ये बहुत जरूरी है. Your x has to be a discrete random variable. If x is corresponding to a continuous random variable, PMF is not applicable for that. So if x is a discrete random variable such that P of x is equal to xi is equal to pi, where x is taking various values like x1, x2, x3 till xn, then P of I is called as probability mass function. So there are two important concepts that we are going to learn today. One is the PMF, other is the PDF. So talking about PMF is the probability mass function. So if x takes a discrete random variable, so if x is a discrete random variable such that P of x is equal to xi is equal to pi, that is x is taking different values, right? x1, x2, x3, xn. So if P of x is equal to xi is equal to pi, then this pi is called as probability mass function. We'll try to understand it more further, but this is the definition. So probability mass function says that if x is a discrete random variable, most importantly for continuous random variable, PMF apply nahi karta. So if x is a discrete random variable, then P of x is equal to xi is equal to pi, where x can take any value, right? x1, x2, x3 till xn, and pi is the probability mass function. So if I just draw the table for you, so this will take values x1, x2, x3, so on till xn. And the probability of every particular value occurring can be given as P1, P2, P3 till Pn, right? So the properties of PMF can be told as, I repeat myself, properties of PMF, that is probability mass function. A is P of x is equal to xi is greater than or equal to 0. That means greater than or equal to 0. That means any probability cannot take a negative value, right? What is P of x is equal to xi? This is nothing else than pi, right? So any probability cannot be less than 0, cannot take a negative value. Either it can be 0 or either it can be greater than 0. The B part is, for I is equal to 1 to infinity, P of x is equal to xi is equal to 1. So this is the basic property, which means that if I add P1, P2 till Pn, the value is equal to 1. Okay. So there are two kinds of distributions. One is the probability mass function. One is the probability density function. If I talk about probability mass function, if x is a discrete random variable, where probability of x is equal to xi is equal to pi, and x is equal to x1, x2, x3 till xn, then P of I, this value P of I is called as the probability mass function. So you have a table, if you see, where x is taking different values, x1, x2, x3 till xn. And the corresponding probability is P1, P2, P3 till Pn. So what is the probability of PMF? Probability of PMF is that every value, every P1, P2, P3, P3, Pn is going to be greater than or equal to 0, A. And secondly, if you add all these values, is going to be equal to 1. So that is the property of PMF. Okay. The next point we'll be talking about PDF. After this, we'll try to solve a numerical also, when we'll understand better, but still. So you have a probability density function. So what do you mean by probability density function? That is given as PDF. So as I told you that your probability mass function is for discrete random variable. So your probability density function X will be for continuous random variable. So that is very important. So if X is a continuous random variable, then PDF can be applicable for the random variable, wherein the representation is given as this. As you know, in terms of your PMF, it was given as P of I. Here it is given as small f. Be very careful. Small f, capital X of X. This is the PDF. So the probability density function is basically given as with a random variable X, which is a continuous random variable. And this is the PDF of it. So what are the properties? As we learned properties for PMF, wherein every value of PMF should be greater than or equal to 0 and addition should be equal to 1. Similarly, the properties of PDF is firstly, f of x is always greater than or equal to 0. A point. So you cannot have a negative probability density function. The next point is integral minus infinity to infinity fx of x dx is equal to 1. And the C point is this is very important. So if I want to find out the probability from point A to point B, it's nothing else than the integration from A to B fx of x dx. So I hope that the basic properties and the basic understanding is clear so that we can go to solve numerical on each time. Okay, so I'll just revise with you again the concept. So there are two kind of distribution, the probability mass function, the probability density function. So the probability mass function says that if x is a discrete random variable, I repeat myself, if x is a discrete random variable and x takes multiple values, x1, x2, x3 till xn, then in that case, your P of x is equal to xi is equal to pi. This pi is nothing else than the PMF. And the property says that this pi, every value of pi, is going to be greater than or equal to 0. And if you add all these values, P1 plus P2 plus P3 till Pn, that will be equal to 1. The next one will be the probability density function. I repeat myself, the next property is the probability density function, where x is a continuous random variable. So if x is a continuous random variable, the representation is given as small fx of x. And the properties is, it is greater than or equal to 0. That means a non-negative value. Integration minus infinity to f of x of d is equal to 1. And the probability of a to b is going to be integration a to b fx of x dx. So we'll solve a numerical now. A random variable x has the following probability distribution. So random variable x has the following probability distribution. So I'll just draw this table. Okay. So x is equal to x. And here is given as p of x is equal to x. And the value taken by x is -2, -1, 0, 1, 2, and let's take another box having 3. The PMF probability value for each value of x is given as so there's a random variable x which is a discrete random variable, and this is the table -2, -1, 0, 1, 2, 3, and this is the corresponding probability to every random variable, every value of random variable. So the question is find k value and b probability which is between -2 x 2. So what did we learn? The second property of PMF. In PMF, we learned that the addition of all the probabilities is equal to 1. Similarly, so what you learn from here? So we can say I is equal to 1 to infinity, P of I is equal to 1, right? Therefore, just add all these values. 0.1 K, 0.1 plus K plus 0.2 plus 2K plus 0.3 plus 3K is equal to 1. So there are different values of probability. 0.1 plus K, 0.2 plus 2K, 0.3 plus 3K, 0.3 plus 3K is equal to 1. Okay. So this is the most important thing. I think there is some issue here. It's getting again and again this. Okay. So this is a value. So what will be the final answer? K is equal to K ka value is 0.066. This is the value of K. So this is what you have over here. That this is the table given to you. That x is taking different values, -2, -1, 0, 1, 2, 3. This is the corresponding values of x. So when you have to find out the value of k, add all the values plus 0.3k as I told you, which is equal to 1, and then get the value of k. What is the second point? So what is the second point? What is the probability of P existing between -2 to 2? So what is the probability of P existing between -2 to 2? So that is P of x is equal to -2 plus P of x is equal to -1 plus P of x is equal to 0 plus P of x is equal to 1. So your probability of random variable existing between -2 to 2 is given as, so what is P of x is equal to -2? 0.1 plus, what is the value of k? 0.006, right? So 0.066 plus 0.2 plus x is equal to 1 is given as 2k. So that will be equal to 0.133, which is equal to 0.5. So this is the final answer. So this is the way in which you will solve the question. So know what is PMF, what is PDF, and these are the this is a numerical on PMF. If you want a numerical on PDF also, please comment in the comment section. I'll bring up another video with numericals on PDF. So thank you so much, guys. God bless.